This is a video on the moment of inertia. The question states, find the moment of inertia about the line x equals 2 for the lamina bounded by the curves y equals the square root of 4 minus x squared and y equals 0. With the density function, rho is equal to x squared plus y squared. So let's start by sketching a picture. Y equals the square root of 4 minus x squared. That's a semicircle of radius 2. Y equals 0 is just the x-axis. And I'm looking for the moment of inertia about the line x equals 2. That's this vertical line at x equals 2. To find the moment of inertia about a line, I look at the distance from a point to the line. So if I take a point x comma y, and I want the distance from x comma y to this line x equals 2, that's a horizontal distance. And that distance will be the distance from the y-axis to the line x equals 2, or just 2, minus the distance from the y-axis to the point, and that's x. So that distance will just be 2 minus x. So the moment of inertia formula says that the moment of inertia about a line is the integral over the region of the square of that distance, so 2 minus x quantity squared, times a density function, x squared plus y squared, times dA. So I have a semicircle for my region. It's a lot easier to use polar coordinates when I'm working with semicircles. The semicircle y equals root 4 minus x squared has equation just r equals 2 in polar coordinates. So I can convert to polar coordinates and say that this is the integral. The little man now is going to rotate from the angle 0 all the way to angle pi. So theta goes from 0 to pi. And the radius, the smallest radius is 0, and the largest radius is 2. So r goes from 0 to 2. 2 minus x becomes 2 minus r cosine theta. I still have squared. X squared plus y squared is r squared, and dA becomes r dr d theta. So I could integrate this by squaring this out and then multiplying by r cubed. I'll use some power reduction formulas, and eventually I work this out. But instead, I did it the easy way, and I put this into a calculator, and I got that the moment of inertia about the line x equals 2 for this lamina is equal to 64 pi over 3. And I'm done with the problem.